how to calculate the electrode potential of a cell with hydrogen electrode at two different pressures, P1 and P2. So we need to know what is hydrogen electrode. And here is the figure for hydrogen electrode. The standard hydrogen electrode consists of a platinum electrode coated with platinum black. The electrode is dipped in an acidic solution as we find here, and pure hydrogen gas is bubbled through it. The concentration of both the reduced and the oxidized form of hydrogen is maintained at unity. This implies that the pressure of the hydrogen gas is 1 atmosphere or 1 bar, and the concentration of hydrogen ion in the solution is 1 m. So here is 1 m hydrochloric acid solution. And as you find, the figure illustrates the hydrogen electrode and its composition. Now there is a question relating to this hydrogen electrode. And the question is, for the following cell with hydrogen electrode at two different pressures, P1 and P2. Here is the composition of the hydrogen electrode. And as we know, the hydrogen electrode composition is represented this way. And there is the EMF. We have to find out which one is the correct option representing the EMF of the hydrogen electrode at different pressures. So we have to calculate. It calls for certain calculations, stepwise calculation. The first step is calculate the electrode potential of each hydrogen electrode separately using Nernst equation, and then find out the difference to get the cell constant. We know what is Nernst equation, and very well we can say that E, that is the electrode potential, is equal to E naught electrode potential. Standard electrode potential is denoted by E naught minus RT by NF ln P hydrogen, pressure of hydrogen, upon the concentration of hydrogen raised to power 2. Since E naught is 0 volts for hydrogen electrode, the equation becomes very simple and we can ignore this E naught. And it is now E is equal to minus RT by NF ln PH2 upon hydrogen ion square. Now, what is the value of N here? N is 2 for transfer of electrons. And therefore, if you substitute the value of N 2 here, we get RT by 2F ln PH2 upon H and raised to power 2. Second step, we need to determine the anode and cathode. In concentration cell, the electrode with lower pressure of hydrogen will act as anode, where oxidation occurs. With higher pressure, the hydrogen will act as a cathode. Assuming we have to assume that P1 is lesser than P2, then the left electrode P1 is anode, while the right electrode P2 would serve as cathode. Accordingly, we can find out the value of E anode and E cathode as represented here. And then we can substitute the values in step 3, that E cell is equal to E cathode minus E anode. When you substitute the values and simplify, you get the result that E cell is equal to RT by 2F 2.303 log P1 upon P2. Of course, it is log to the base 10. So that way we can find out. And coming back to the question again, we can definitely say that option B is correct. That is 2.303 RT by 2F log P1 upon P2. Okay, it has been a very good question and provides an insight about how the composition of a cell containing hydrogen electrode at different pressures can be written, and at the same time how the EMF is calculated. Okay, thank you very much. Please do subscribe to our channel.